Okay, so now I'll start with another new topic, that is steroids. Okay, so now, we'll start with your steroid molecule. Okay, and before that, let me tell you your different hormones present in your body. Okay, some sex hormones are there. Okay, like your testosterone, progesterone. Okay, and like your androsterone. So all these are coming under your steroids. Okay, so how it is classified? These steroid hormones. Okay, these are classified means chemically into four major categories. One is your steroid hormones. Example is your progesterone. Okay, then peptide hormones. Example is your insulin. Okay, insulin is a peptide hormones. Then amino acid derivatives, that is epinephrine, and prostaglandins and related compounds. These are the chemical classifications of hormones. Okay, and as you know that hormones are chemically messengers that transport signals from one to another. Okay, so there are four categories depending, I mean, the chemical classification, as you know. One is steroid hormones. Example is your progesterone, as I said, peptide hormones, insulin, amino acid derivatives, epinephrine, prostaglandin, and related compounds. Okay, mechanism of hormone action. So you can say peptide hormones and catecholamines bind to the cell surface receptors. So these peptide hormones or catecholamines, they will bind to the cell surface receptors. Whatever the receptors are present on the cell surface, it will bind to that. Then steroid and thyroid act via intracellular receptors. So your question will come, how the steroid hormones are acting on the body. So it is acting on the body by mechanism, what is that? Intracellular receptor. Okay. We'll see the structure of steroid hormones. As I told, steroids are lipophilic molecules. Okay, and all steroids except calcitriol have cyclopentanoperhydrophenanthrene structure. So you can say except your calcitriol, all other steroids have your stearin cyclopentanoperhydrophenanthrene nucleus. Okay, so this is the cyclopentanoperhydrophenanthrene nucleus. This is the nucleus for this one. Okay, so all the steroids are having this nucleus. Okay, stearin. This is called so you can say stearin nucleus. Okay, steroids except what? Can remember this one. Okay, and as you can see, this is your numbering system of the your steroids. How we are giving the number? So four nucleus are there. As you can see, A, B, C, D. So last nucleus is your 5-membered rings. So these three are your 6-membered rings. Okay, this is the phenanthrene nucleus, anthracene, and phenanthrene. So this is a phenanthrene nucleus. Okay, so as you can see here, to the 3 6-membered rings, 1 5-membered ring is fused. So how we are numbering here? We are generally numbering from starting from here, 1 2 3 4, and where the ring is fused, that position is named as your 5th, 6th. So that position is numbered as 5th, then 6th, 7th, 8 in this way, 9th, then 10th here. Again we'll start from here, 11, 12, 13, 14, 15, 17. So this is a 17-membered steroids. Okay, as you have seen here. The parenteral precursor of steroids, cholesterol. Okay, cholesterol is the parenteral precursor for the steroids. Okay, all the steroids are manufactured or can be synthesized from your cholesterol. Okay, cholesterol, as you can see here, this is the structure for cholesterol. This is setting up to this. Okay, so after that 18, 19, 20, 21, 22, 23. So like that. Okay, sorry, as you can see, sorry, up to this one, your 17. Okay, after that what to have, this is your, as you can see here, this is the 18, this is the 19, then your as you can see, this is the numbering system for cholesterol. Okay, Next is your, as you can see from here, we are starting as your 21, okay, 22, 23, 24, 25, 26, 27. Okay, so this is 26, sorry, this is the 27 nucleus. Okay, so these are the different naming for the cholesterol. Now, how we are giving the nomenclature for the your steroid compounds, or we can say cholesterol. Okay. And as I told, calcitriol is having which nucleus? It is not having the stearin nucleus. It is different from other steroids. Okay. And steroid hormone classes, as I told you, what are the different classes of steroids? One is your progestins, glucocorticoids, mineralocorticoids, androgens, estrogens, vitamin D. So these are the different hormone classes. Okay. Progestins, glucocorticoids, mineralocorticoids, androgens, estrogens, and vitamin D. Okay. Now we'll see about your steroid hormones. What are those? Are not packaged but synthesized and immediately released. Okay. And are all derived from the same parent compound, that is your cholesterol. All steroid hormones. Okay. They are derived from the same parent compound. Which is the parent compound? Your cholesterol. And cholesterol is how many ring structure? It is 27 carbon rings containing structure. Okay. And enzymes which produce steroid hormones from cholesterol are located in mitochondria and smooth endoplasmic reticulum. Okay, so enzymes which are producing your steroid hormones mainly, they are from cholesterol. From cholesterol, generally, your all the steroid hormones are biosynthesized. Okay, so from cholesterol, how all other steroid hormones are present, you prepare or manufactured? They are present means your and are located in what, where it will be produced? Your mitochondria and smooth endoplasmic reticulum. These are the enzymes present in that which will produce your different steroid hormones from the cholesterol. Okay, the enzymes which are present in mitochondria as well as your smooth endoplasmic reticulum, they are responsible to produce your steroid hormones from your cholesterol. Okay, so this is what I want to tell you about this one. Okay, next, as you can see here, steroids are lipid soluble, are freely permeable to membranes, so are not stored in cells. So these are not stored in cells. Okay, so these are freely permeable to the membranes. Why? Because it is lipid soluble. Okay, this is lipid soluble. Because of that, know that the cell membrane is lipid permeable, and you know that if it is lipid soluble, you can say the steroids are lipid soluble. The steroids are also freely permeable to the membranes. Okay, and steroids are not water soluble, so have to be carried in the blood complex to specific binding globulins. So what it says, as the steroids are not water soluble, then how they will be carried out? By the blood. So they will be carried out the blood by complexing with one reagent, that is your globulin, with one protein, that is your globulin. Okay, so steroids will form a complex with globulin, and the complex of your steroid and globulin will be flown by the blood to different organs. Got my point? This is how these are carried out. Okay, so you have to remember this globulin. Example, they will ask you question. Okay, so steroids are forming complex with which of the following protein? Albumin, globulin. So they will give you some protein. So your answer is your which one? Can you tell me which one is your answer? So steroid hormones are complexed with one of the protein to flow in the blood from one organ to another, one position to another position. Can you tell me which of the protein is responsible to form the complex with your steroid hormones? Okay, very good. Steroids binding globulin carries testosterone and estradiol. So these are the six steroid or six hormones which are binding to the protein globulin, as I told you, and carries testosterone and your estradiol. Okay, so corticosteroid binding globulin carries your cortisol. Okay, corticosteroid will bind globulin and it will carry your cortisol. Okay, and in some cases Steroid is secreted by one cell and is converted to the active by the target cell. So what it says, in some cases steroid is secreted by one cell. Okay, one cell will secrete and is converted to the active steroid by the target cell. One target cell will be there, it will convert that one. Okay, it will convert the active steroid, convert to active steroid. Okay, so suppose example, as I told you, androgen is secreted by the gonads. Okay, androgen is secreted by the gonads and is converted into estrogen in the brain. So it will be converted into estrogen in the brain. So you remember this one, androgen secreted by gonads and converted to estrogen in the brain. Okay, so this is how I told you. Some cases those will be secreted by somebody and those will be converted into that active form by a target cell. Okay, so as we have told, steroid hormones play important role in what? Carbohydrate regulation, mineral balance and reproductive functions. So in these cases, these are helpful steroid hormones. Okay, so these are helpful in case of your what? It is playing the role in your body like your carbohydrate. It is regulating the carbohydrate like your glucocorticoids. Okay, and it is maintaining the mineral. It is balancing the mineral in the body. That is mineralocorticoids. Okay, and reproductive functions also. Gonadal steroids. Okay, so these are the different roles of steroid hormones. Okay. Yes, important. If you are feeling not important, you can. Okay, why you want to leave the class? Daljit, you are asking. Okay, then you listen carefully. If you are not, it may be important, it may not be important. You have to listen the class. Okay. If you are not, it's my suggestion to you. You have to remember. For that only you are studying, na. If you not remember, then how you can study? Hmm? You are saying it's too much to remember. You have to remember it too much thing. Then how you'll make your future brighter? It will not work. You will think it's like hills. So you cannot be a successful person in your future. So you should have always patience. That is my suggestion to all the people. Okay, always whenever I'm teaching to all the people, I'm suggesting them to be always disciplined and always to be patient. Okay. So okay, whatever may be. If you're not interested, you can leave the class. Okay. Anyway, I told you what are the different roles of the steroids, and as I told, steroids also play important role in inflammatory responses, inflammations. It also helps in inflammations, and then stress responses, bone metabolism, cardiovascular fitness, and your behavior, cognition, and mood. All these are responsible for your steroid hormones. Okay, now we'll see one by one. One is your adrenal cortex. Okay, composed of 3 layers. What are those? It is composed of these things. You don't remember how they are consisting of. Okay, so this adrenal cortex generally it is having 3 zones: your outer zone, middle zone, and inner zone. Okay, and this adrenal cortex, that outer zone is known as your zona glomerulosa, and middle zone is known as zona fasciculata, and inner zone is known as zona reticularis. Okay, glomerulosa, fasciculata, and reticularis. Okay, so you can remember that is your GFR. GFR means glomerulosa, fasciculata, reticularis. Okay, these are outer zone, middle zone, and inner zone. So outer zone, it is secreting your aldosterone. It is producing aldosterone. Whereas that is a mineralocorticoid, as I told you, how it is helping in different regulations of your minerals or fat or carbohydrate. Okay. Then middle zone, it is known as your what? Fasciculata, and it is producing cortisol. Okay. That is known as your glucocorticoid. And inner zone, that is nothing but your what? Zona reticularis, and it is responsible to produce androgens. So these are the things we have to remember. Adrenal cortex, 3 layers: outer zone, middle zone, inner zone, or you can say glomerulosa, fasciculata, and reticularis. Glomerulosa, it is producing aldosterone, and your fasciculata, it is producing cortisol, and reticularis, it is producing androgens. Okay. Then corpus luteum and ovary. You know that corpus luteum and ovary, these are producing progesterone and estradiol. Okay, these are the two hormones secreted by these two organs. Okay, it is mainly producing testosterone, that is dihydrotestosterone. This is a male reproductive hormone, testosterone. Okay, so dihydrotestosterone, DHT, that is called DHT. Okay, dihydro testosterone, DHT. Okay, as you can see, progestins are the biosynthetic precursors of all other steroid hormones. Because you are studying the chemistry of steroids now, so you have to remember all this. So first starting material is your what? Precursor is your cholesterol. From cholesterol, it is producing progestins. So progestins can regulate glucocorticoids or mineralocorticoids or androgens, or indirectly we can say controlling or it is regulating estrogens. Got my point? So cholesterol is the starting precursor, and it is forming a intermediate, that is progestin. It is regulating three different steroids like your glucocorticoids, mineralocorticoids, and your androsterone. Okay, aldosterone or cortisol or your progesterone or estrogen. All these it is your regulating. Okay. Now you can see this is pregnenolone. Okay, produced directly from the cholesterol and the precursor molecule for all C18, C19 and C21 steroids. Okay, this is the precursor molecule for all what? C18, C19 and C21 steroids. Okay, so this is the structure for your pregnenolone. Okay, it is directly produced from your cholesterol. Got my point? This is about your pregnenolone. Okay, pregnenolone. Got my point? Then progesterone, as you can see, progestin produced directly from the whatever we have prepared right now, pregnenolone. So from pregnenolone we can prepare also progesterone directly. Okay, and this is secreted naturally. It is secreted from your corpus luteum. Okay, as I told you, progesterone, corpus luteum. Estradiol, it is from your ovary. Okay, secreted from this one. Then it will maintain the uterine endometrium for implantation. Implantation during the birth of a small, means your fetus. That time, what is happening when your after a successful intercourse, what will happen? There will be during the ovulation phase. What is happening? Ovum is produced in the female. So that ovum is going to be fertilized by the your sperm. Okay, so in that case, what is happening? It form an embryo. So that embryo should be implanted properly on the uterus wall. Okay, if the uterus wall is not proper, then that is called endometriosis. That disease is called. Okay, so that endometriosis, in that case, we should have to increase the endometrium. In that case, what is happening? Estradiol injections we are supplying to the female when they are pregnant. So what will happen when they will be supplied with your estradiol, or if they will be having estradiol natural secretion will be more in their body, then automatically that embryo will be implanted properly. Okay, so that what will happen? It will convert. There will be no miscarriage happened. Got my point? During pregnancy it is required. Got my point, all of you? What is the use of your estradiol? Understood? All of you clear? What is the necessity of your estradiol? Understood? No? Or shall I explain again? Have you understood or shall I explain again? Okay, all of you there or not? Nobody is responding. No, shall I explain again or have you understood, all of you? Okay, Shravant is telling to explain. Okay, what I said, when one if fertilization over, okay, means one sperm is going to fertilize the ovum. So after fertilization, what will happen? One embryo will be formed. Embryo. Okay, growth of embryo will lead to baby. Okay, so there will be embryo will be formed. That embryo should be implanted properly on the uterus wall. If it won't be implanted, will happen, it will be miscarried. Okay, so to have proper implantation, the endometrium wall should be having proper thickness. And how the endometrium wall is maintained? By one hormone, that is your estradiol. Okay, so that estradiol will be secreted by the corpus luteum. What my point? Okay, so that is what I am telling you. Okay, okay, so these are about your understood, all of you or not? So there will be no more miscarriage will be made. So after a gestation period of 10 months, 9 months, 10 days, so there will be full, they can give birth to the baby. Okay. So if it will not be implanted properly, then there will be miscarriage. What my point? I am telling you. Okay, next is your another example is your estradiol. As I told you, this is C18 nucleus. Progesterone, it is a C21 nucleus. Okay, you have to remember progesterone C21 nucleus, estradiol C18 nucleus. Okay, as you can see here, in case of estradiol, the female regulates gonadotroph secretion in ovarian cycle. It will regulate the in case of female, it will regulate the gonadotroph secretion in ovarian cycle, and it will maintains uterine endometrium, as I told you in the before. Okay, differentiation of mammalian gland, it will differentiate between the mammalian gland. Then responsible mammalian gland means if estradiol will be more, the mammary glands will be there, as in case of female. So in case of female, the estradiol is more, that's why they are having mammary gland. But in case of males, there is less estradiol, that's why they are not having means that mammary glands. Okay, in case of male, the estradiol will be more, then that disease is called your gynecomastia. As you know that one, gynecomastia. You know that one? What is gynecomastia? Gynecomastia is happened because of increase in estradiol content in male. Got my point? Okay. What estradiol? Then we'll see about your testosterone. Okay. In case of testosterone, it is a C19 nucleus. Progesterone C21. Estradiol C18, testosterone C19 nucleus. Okay, as you can see the structure for this one. Are you drawing this structure, whatever I am teaching you? Are you drawing, all of you? Not. Okay, anyway. So testosterone C19, okay, and dehydro, as you can see this one, testosterone, what is the work of testosterone? After conversion to dihydrotestosterone, production of small sperm proteins in Sertoli cells, okay, and responsible for secondary male sex characteristics and produced from progesterone. This is produced from progesterone. This testosterone, it is produced from progesterone, and it is responsible for the secondary male sex character. Secondary male sex character means like your increase in sex attraction. Second one is your increase in your what is that called, your pubic hair. Okay, all these are your secondary cells, sex characters. So this is the hormone responsible for increasing the or responsible for your secondary sex characters. Okay. Not able to listen, students. Are you able to hear me? No? All of you able to hear my voice? Okay, okay. Anyway, next I'll okay. Okay. I was telling that testosterone, it's a C19 nucleus and a C19 compound, and mainly it is able to produce. It is mainly responsible to produce sperm from your Sertoli cells. Okay, and it is mainly responsible for developing the secondary male sex characteristics. So this is the structure for testosterone. Okay, so all the structure, whatever I am saying, so you are drawing the structure, all of you. Are you drawing or not? Are you drawing? Okay. One compound is there, that is your dehydroepiandrosterone. Okay, what is that? Dehydroepiandrosterone. So this is a weak androgen which can be converted to estrogen, and it is having various protective effects, and it plays a running process, it aging process. Okay. If this dehydroepiandrosterone will be reduced, then you will be having you will be or on your open aging. So when you will be having more age, that time the dehydroepiandrosterone level will be less, and it is regulating mainly your NAD plus coenzymes. Okay, so this is the main function of your what, dehydroepiandrosterone. Another one, aldosterone. What is that? The principal mineralocorticoid this is, and it is mainly produced from your progesterone in zona glomerulosa and fasciculata reticularis. So glomerulosa only this one is produced, okay, from the progesterone, and this aldosterone, as I told, okay, and which is a glucocorticoid, sorry, mineral corticoid, okay, and it mainly causes sodium ion uptake via conductance channel. Okay, so it is mainly responsible for what? Sodium ion uptake, and it occurs in high levels during stress. So when you will be having, when you are under stress, that time the aldosterone level will be more, and it will raise the blood pressure and fluid volume. So when you are under stress or under tension, so your blood pressure will be increased because of your aldosterone level increased. Got my point? Question will be coming like that. The increase in blood pressure is because of is responsible for increase in concentration of four options to give: aldosterone, cortisol, okay, progesterone, and your any other progesterone and estradiol. Tell me which is the correct answer. Which hormone, increase in hormone, is responsible for increase in blood pressure? Can anybody? So is your aldosterone. Now, so you can remember this is a C21 nucleus. This is the structure for aldosterone. Okay, and cortisol, as you can see, this is a dominant glucocorticoid in humans. Cortisol is glucocorticoid. Aldosterone is a mineralocorticoid. So this will be, cortisol means it is a glucocorticoid, means it will be synthesized by your zona fasciculata. Okay, zona fasciculata cortex, and state adaptation through various cellular phenotypic expression states. So under stress, it will make you adjusted to that conditions. If cortisol concentration, if cortisol concentration will be more, then automatically the blood pressure will be managed by the cortisol level. If cortisol level will be less, then you will feel a rise in blood pressure. Got my point? So increase aldosterone will cause your blood pressure, but increase in cortisol level will manage the blood pressure. Got my point? So that is what, that it will maintain during the stress conditions, this cortisols. Okay, And as you can see, another one compound, that is calcitriol. As I told you, this is different from your others, having different structure. This is not containing the phenanthrene nucleus, as I told you. Okay, as you can see here, the breakage, you can say this is not containing the phenanthrene nucleus. This is the compound calcitriol. Okay, and causes synthesis calcium transport protein, and it is regulating calcium and phosphorus homeostasis. Okay, this one, which one? Your 125 hydroxy vitamin D3. So calcitriol is nothing but the vitamin D3. Okay, it will maintain the homeostasis. It will maintain the body temperature constant. Okay, then we'll see the in the next class, that is your biosynthesis of steroids. Up to this we have completed. Next class we'll see the biosynthesis of steroid hormones. How